Okay, well, the determinant is this. If I did it correctly, do we agree?
Yes.
So the solution,
Right. We have an
general
imaginary
solution is
report.
this, which is two solutions. We get this.
Right.
Which means, using Euler's identity and so forth, without going into detail, the algebra is trivial, at least to us, and it is to you guys. Y1 is e to the 3/2 t times the cosine of that square root of 11 over 2 times t, and plus I times the sine of the same thing. And y2, same expression, but with a minus I times the sine. Okay?
Right.
So these are solutions. Now we could go ahead and do the Wronskian of this, determine that they're linearly independent. Okay? It's a little easier to use a simple linear combination. So I'll say these are solutions, and so my grammar's terrible. So is any so is any pair of linear combinations. So any linearly independent pair of linear combinations is a solution set. How about that? Just make my statement literate. Okay? And the linearly independent pair I want and y1 and y2 are not vectors. Habit of writing a vector symbol there. Okay, well, if I add these two, the sine terms are going to go away, right? So I'm going to get double the e to the 3/2 t times the cosine. Okay? Well, I take half of that, so I just get an e to the 3/2 t. Gotta sand this board down, it's not smooth enough. Okay, right? And 1/2 of y1 minus y2 is e to the 3/2 t, and I don't want 1/2, actually I want negative I over 2, because I want a real solution, okay? But the y1 minus y2 gives me e to the 3/2 times the sine of square root 11 over 2 times the I, right? If I multiply by I, then I get a negative of this. And actually, okay, if I just do y1 minus y2, I get 2 times this times I. Then multiplying by I get negative of 2 times this, and dividing by 2, taking the negative and dividing by 2, I get this. Okay, algebra is really simple. Work it out and you'll see how it works if you don't see it. So there are my two linearly independent solutions. So the solution set, well, and I left something off here. Of course, I've got to have my x1, x2. So when I said this wasn't a vector, I was wrong. It is a vector. Okay?
Right.
I don't know, things are jumbled. I'll blame it on allergy season, but that's not really what it is. Okay, so we have this times our x1, x2. and this times our x1, x2. Now we have to take these solutions and plug them back into this equation to find our x1 and x2. Okay?
Right.
So let's go ahead and do that.